This video will cover just the square roots, and then another video will cover the cube roots when we get past number 21. So this will essentially take us from 1 through 21. So what we are going to do is talk about radicals, or we usually know them as square roots. If you look down below, number 1 says the square root of 81. So the square root sign is a special one because we don't have to write a number in. Technically you could write a 2, but since it's used so often we don't write anything. So it says the nth root of a number a can be written as this radical expression. So the little n outside the radical sign, which again we think of as a square root sign, but it's actually a radical sign, and then the a underneath. Okay, so this is the nth root. This is your radical sign. And then this is what we call our base number. Okay, so another name for your root is an index. So the little star says if there is no index, it is assumed that it is 2 square root. So we don't write a 2 for the square root. We just write the radical sign. So radicals can have more than one root. Square roots, if you take the square root of 16, technically you get 4 or -4 because -4 squared is also 16. But we are only going to be using the positive one unless it asks us specifically to find the negative one. So we'll list a few of the perfect squares, but you have this sheet of paper. Let me do this quick. You have this sheet of paper with you that shows the perfect squares and the perfect cubes, and this actually has the first 20. You should be able to get the first 10 sort of memorized, or at least saying, okay, I know that 5 squared is 25, 6 squared is 36, so on and so forth. All right, so we're not going to list them because you have them there on that little sheet of paper. So we're going to go right to here. So if we look at number 1, square root of 81, 81 is on your list. Again, when you're thinking of the square root, you're thinking what times itself gives me this number. So when you look at 81 on your list, that's a perfect square, so the square root goes to the left, and it is 9. All right, so when you see a number in this perfect square column under the square root sign, then the square root is this number over to the left. So the square root of 81 is 9. So our answer for number 1 is just 9. $484 is not on our list, so you need to find your square root button. Again, for those of you using most of the calculators that I have, you do second, and then there's an x squared button. So your second button, and then you have an x squared button, and that should show up as the square root sign. So if you hit second squared, which shows you the square root sign of 484, you should get 22. Number 3, either you can find it on your list, or hopefully you know that 8 times 8 is 64. These next 3 have numbers out in front. So remember in math, if there is no symbol in between the two, that is multiplication. So this means 18 times the square root of 4. The square root of 4 is 2, so you could cross it off or you could rewrite it either way. 18 times 2 is 36. So your final answer for number 4 should be 36. All right, so again, this means 3 times, if you just run a cross off, square root of 256 is 16. Again, either it's on your sheet, or you can type in the square root of 256 in your calculator. So 3 times 16 should give us 48. Number 6, you have a negative 5 times the square root of 121 is 11. So negative 5 times 11 is negative 55. So it is okay to have a negative for your final answer. Our last 3 are fractions. When you have a fraction that is under the square root, you split it into 2 separate ones. So we do the square root of 1 over the square root of 16. If you're able to know to do that without writing the 2 separate square roots, that's fine. I will always do it so you can see where the numbers come from. So the square root of 1 is just 1. The square root of 16 is 4. So 1/4 is your final answer. Number 8, we have the square root of 9 over the square root of 100. That would be 3 over 10. And number 9, square root of 25 over the square root of 49. That would give us 5 over 7. All right, so all of those problems have perfect squares. So you are able to take the square root and get a whole number. These next ones, you are not going to have a perfect square. So if you try to type in the square root of 24, you are going to get a decimal that you're not able to change to a fraction. So the steps are right there. This is where that little sheet of paper with all the perfect squares is going to come in handy. So the first thing you need to do is find the largest perfect square that the radicand, so that's 24, the number inside, can be divisible by. So if we look at 24, there's a few different ways to do it. You could list out all of the factors of 24. The easiest way, I think, is to just look at our list and see which of our perfect squares goes into 24. So hopefully we know this is 4 times 6. So the way I do it is I draw a little arrow, 4 times 6, square root sign, square root sign. The square root of 4 is 2. The square root of 6 comes along. So 2 square root of 6 is considered the simplified version of the square root of 24. So that is going to be your job for all of these, is to figure out what perfect square goes in and then actually take that perfect square out. Now, number 11 gets tricky, and I'm going to show you 2 different ways to do it. The first way, most of us know that 4 goes into 48. So if we break this down into 4 times 12, that's fine. Square root of 4, square root of 12, we get 2 square root of 12. The problem is that there's another perfect square in 12. So you are going to have to do this whole process twice. So that means you have to do this whole process again with 12. So you need to break 12 into 4 times 3, square root, square root. So we have this 2 out in front still that you have to bring along. So we would have 2 times the square root of 3. So our final answer is 4 square root of 3. So it's not incorrect to do it that way. It will just take a lot longer. So the steps say that you're supposed to find the largest perfect square that goes in. The way to know that you find the largest one is, instead of having to do this all twice, you can say, oh, 12, that's not right because 4 goes into it. So if 4 goes in twice, that means 16 will have to go in. The other way is to take half of whatever your number is. So 48 divided by 2 is 24. Now 2 nor 24 are perfect squares, but that tells us where to start on our list. And here's what I mean. 24 would fall in between the 16 and the 25. So you would not check 25 because you know that it can't go in. The first number you would want to check is 16. So you would take 48 divided by 16 and get 3. So to do this the fastest, you would take this into 16 times 3. So square root, that's how we get our 4 square root of 3. Okay, again, I know that was super confusing, so I'll do that for a bunch of these. Okay, so 72. I'm not sure what goes into 72. All right, so if I divide this by 2, I get 36. So you should realize 36 is on our list. Now, a lot of people think, oh, 72, I should use 9 times 8. Well, the problem with using 9 times 8 is that 8 has another perfect square in it. So we want to right away use 36 and 2. Square root, square root. Square root of 36 is 6, and then the 2 comes along underneath the square root sign. If I look at 63, 63 divided by 2 is 31.5. So again, what that means is I go to my list, 31.5, the closest, it would fall in between the 25 and the 36. So 25 is the first perfect square you would want to try. So hopefully you know that 25 doesn't go into 63, but if you're not sure, divide and you get a fraction, or a decimal. So then you're going to try 63 divided by 16. You're going to work your way up that list. That doesn't work. 63 divided by 9 gives us 7. So as you work your way up your list, you find that this is 9 times 7. Again, most of us know that, but I'm just showing you the process to go through that. Square root, square root. Square root of 9 is 3. Square root of 7. So 14, 90 divided by 2 is 45. Sorry. Divided by 2 is 45. So on your list, again, you're going to figure out where that means to start. You would start at 36. 90 divided by 36 doesn't work. 90 divided by 25 doesn't work. 90 divided by 16 doesn't work. So 90 divided by 9 is the first one that will work. So you're going to do 9 times 10. Again, you do not have to do this process if you know that it's 9 times 10. So square root of 9 is 3, square root of 10. $175. If you want to do the process, 175 divided by 2 is 87.5. So when we look at our list, our first one we would check is 81. So 175 divided by 81 doesn't work, divided by 64 doesn't work, 49 doesn't work, 36 doesn't work, 25 is what works. So 175 is 25 times 7. Square root, 5 square root of 7. So once you find the perfect square that goes in, hopefully it's not too bad. It's just finding the biggest perfect square. Okay, 162 divided by 2 is 81. So there's our perfect square right away. Again, a lot of people check 4 first, or 16 or that sort of thing, but 81 is your biggest one. So 81 times 2, square root, 9 square root of 2. So 245 divided by 2 gives us 122.5. So when you go down your list, 121 doesn't go in, 100 doesn't go in, 81 doesn't go in, 64 doesn't go in, 49 is what goes in 5 times. So 49 times 5. Square root, 7 square root of 5. The video is about out of time, so I'm just going to leave the rest of the answers up here. You can ask questions when you have them. So again, you need to find the number on your perfect square list that goes into the underneath number. Take that square out and then leave the other number underneath.